Hi everybody, I'm here at Retro City Studio in Philadelphia, and they've really kindly let me kind of spend the day here pulling stuff out and taking the lid off, unbelievably. And what we're going to look at right now is this amazing hunk of a compressor, the Neve 33609. It is a diode compressor. What does that mean? Well, we'll get into it. I'm also excited to take the lid off just because I've never seen inside one of these things, so let's take a look. You can see from the front panel that the 33609 is a pretty full-featured compressor. It's 2 channels, which can be used as either mono, dual mono independently, or stereo. It's got separate limit and compress functions with your typical threshold, release. They call it recovery in a very charming Britishism. Makeup gain ratio, and then a fast or slow attack and release. Basic stuff. There's this external control thing, which I'll show you on the back, which doesn't really affect what we're going to be talking about, but love this power switch here. This is cool. And meters for each channel. Let's take a look at the back. So this is the external control I was talking about. You can basically control, I think, bypass and some other things through this, and link multiple 33609s. I don't quite understand all that, but so I'm going to skip it. And then, typical balanced inputs and outputs and power. But let's get into the inside of the thing. So I'm going to be honest, I pulled this off the shelf and didn't check the suffix of the part number, just assuming it was vintage, and it is very much not vintage. This is a AMS Neve. This was tested in 2018, so this is a pretty new unit. But nevertheless, we're going to get to see what's inside it. Also, I can point out something kind of new, which is that most of the parts here are surface mount, which is representative of most gear in the world. It's just that we've been looking at vintage stuff, which is mostly through-hole. So through-hole parts go through the board, and then you solder them from the bottom. Surface mount parts sit on the surface, and they're all soldered at the same time in a reflow oven. So much more efficient, but just not as DIY friendly, which is why I don't use it as much. But lots of cool stuff going on here. 3 transformers per channel. These beautiful Grayhill and Elma switches here. As I mentioned in the 1073 video, these switches are pricey, but they're so nice. And really the star of the show here, though, are the transformers. Transformers are such a big part of the Neve sound, and such a big part of the kind of mythic unobtainium aspect of the Neve sound. And that's because in the very beginning, in the late 60s, Neve used this Mariner. Mariner made all the transformers for Neve. And Mariner very quickly went away. And then St. Ives began making the transformers. And since then, the transformers have never really quite been what they were with Mariner. And so even within the same console, the same old vintage Neves, you will find Mariner and St. Ives commingling. And eventually Carnhill either turned into or bought St. Ives, but they were manufactured under the St. Ives name well into the 90s and revised numerous times. And it was just something that Neve themselves were not super picky about. They were not against mixing various revisions in the same board or letting, the transformer company revise it. It's only in retrospect, as the kind of the clone market emerged, that we've become so particular about the transformers. And so AMS Neve at some point went back, and they have kind of the original specification, and they went back to, I believe these say Mariner. I believe these are still made by Carnhill, but could be wrong. It doesn't really matter. What matters is that at some point AMS Neve said, okay, here's the original specification, go back to that, and they have kept that private. And so that's why this says Mariner exclusive specification, meaning these are made just for AMS Neve based on the original spec, and they purport to be, I have not done in-depth testing on this, but they purport to be kind of the only truly authentic transformer out there. So that's the deal with the transformers. There are 3 per channel. We'll talk about why that is in a minute. This is all the power supply over here. This kind of modular power supply block is probably made by a third party that specializes in power supplies. This is not at all uncommon to see a modular block like that. What's important is that we're getting plus 24 volts into the board, which is what all the old Neve stuff runs on. What else have we got going on here? These black, these anodized aluminum blocks are heat sinks for these transistors here. This is a BA340 module, which is an old discrete Neve design, which is a Class AB. So the 33609, just to place it in kind of the history of Neve stuff. In the 60s, late 60s through most of the 70s, Neve was making the 80 series consoles, which was built up of all these building blocks that were all discrete transistors, and they were all Class A. So the classic circuits from that era have names like the 1073, the BA283, the 1272, the 1290, etc., etc. And the 2252 was the original diode bridge compressor that Rupert Neve, according to a video I saw, you can find it on YouTube, he apparently invented this type of compressor and designed it and had it ready to go into the console in 3 to 4 weeks. And part of how he was able to do that, besides being a genius, is that he had all these building blocks to build from. And that got revised, the 2253, the 2254, all the way up to the late 70s where they made it into this rack mount unit called the 33609. And at that point, Neve's circuitry had gone on to Class AB. So Class A means that the transistor is amplifying the signal all the time. A waveform has its kind of its peaks and its valleys. And in Class A, they're all being amplified by the transistor. In Class B, there are 2 transistors sharing the load. One amplifies above kind of the center line, and one amplifies below the center line, which is, so each doesn't have to do quite as much work, but it introduces this issue of crossover distortion. So when they hand off from one transistor to another, sometimes that transition basically is not perfect and there's some distortion. Class AB attempts to be the best of both worlds by having 2 transistors driving the output in a pair like that, with another transistor biasing both of them to be on all the time. So it's kind of like Class B, but instead of switching on and off between the top side and the low side, they kind of crossfade, and it reduces the crossover distortion. So that's the deal with Class AB. So just the big takeaway is we're not in the era of circuitry anymore of the 1073 and the kind of classic Neve era. But this era has its partisans even who claim to like this era better than the Class A era. Anyhow, that's enough about the kind of signal path. Let's talk about this compressor as a compressor and just how unique and kind of interesting it is. And to do that, I'm going to switch over to a block diagram. So as with most vintage gear, we're going to come in with a transformer for our balanced input. But unlike most gear, we're going to stay balanced and go into the gain reduction section fully balanced, which is a kind of interesting fact about this piece. And then we go into a buffer still balanced, so that we can then go into a second transformer and then finally get unbalanced. So that will then go to the next stage here, which is a big gain block, and this is our BA340. That's these heat-sinked things you see here. Okay, the BA340, because it has so much power, is going to drive our output transformer, which gives us our balanced output. So that is our signal path there. The sidechain gets tapped from two different places. First of all, for the compression part of the sidechain, remember there's the compressor and the limiter. So for the compressor part, it comes from right after this transformer, right before the BA340. And the sidechain, remember, is where our audio signal, which is AC, gets rectified into DC, gets manipulated for things like attack, release, makeup gain, threshold, etc. All that's in here. And then it goes, how best to draw this? It's going to go over that, boop, and control the gain reduction here. Sorry, that's a little bit messy. The limit part of the sidechain gets tapped after the BA340. So basically, it's kind of interesting. You could apply more makeup gain here because there's a pot here for the makeup gain that controls the amount of the 340. So the more makeup gain you do, the harder you're going to drive the limiter. So that's kind of interesting. And note that like most compressors we've dealt with in this series, this is feedback because we take the sidechain after the gain reduction. So the gain reduction is seeing its own work reflected back in its control signal. It's a little bit of a mind bender, but that's how we account for some of the nonlinearities and weirdness of compression like this, is by feeding it back into itself. So it's a feedback style compressor, and it's a diode bridge compressor, as I mentioned at the top of the video. And what is that? Well, let's zoom in. We're going to call this our gain reduction breakout here. And so we've got our balanced signal. And in pretty much every type of compressor, except for VCAs, what we're controlling is a voltage divider. And the way that you make a voltage divider is with resistance. So in this case, we have our hot and our cold, our plus and minus, and they each need to be attenuated by this gain reduction. In the FET compressor, we're changing the resistance of a FET. In the opto compressor, we have a light-dependent resistor that's changing its resistance. In this case, we are using diodes. So each one basically has a diode going into the ground. Okay, these are diodes going to the ground. And remember that in a voltage divider, these two resistances, they don't necessarily have to be resistors, but these two resistances control the amount of voltage here at V out. And so as this one gets lower resistance, more signal will go into the ground and less will make it out through here. And now I'm simplifying this circuit, so don't yell at me if this doesn't look exactly like what you see in the schematic. But the basic idea is that diodes, if you've heard or read anything about diodes, what you've probably heard is that they only conduct in one direction, from positive to negative, and they only conduct over a certain voltage. So, for instance, a very common forward voltage for diodes is 0.7 volts. And the way we typically think of diodes is that they don't conduct at all until they reach 0.7 volts, at which point they conduct everything. It's like an on and off switch. Well, that's not quite right. The way that diodes really work, that's kind of a messy piece of paper, well, whatever, is if you were to draw a graph with current here and voltage here, and let's say this is 0.7 volts. What really happens is, okay, so we're here before 0.7 volts, and basically the diode is saying, no, I'm not going to let any current through. But as we get closer to 0.7 volts, it's like, okay, a little bit can come through. And then it really quickly changes its mind. You might even say it exponentially. Technically, it exponentially changes its mind until at 0.7 volts, more or less, it's conducting all the current. It's basically like a 0 ohm resistor or a straight wire. Whereas here, it's like a giga ohm, like infinite resistance resistor. But in between here is the interesting area where Mr. Rupert Neve realized you could make a compressor out of that. And so what he's doing is getting the voltage into this sweet spot and then moving us up and down this little curve here via the DC voltage, via the DC bias on the diode. So it's just so clever that he basically took the natural kind of exponential voltage current curve of diodes, and he's generating a DC control voltage from the side chain here. A very small voltage, because once you go to 0.7 volts, this thing's not a resistor at all. So he's riding a very small little threshold here, which changes the resistance of these diodes. So I hope that makes sense. It's very clever. I mean, one of the big takeaways is that you need to, first of all, lower the audio level so that it is not going up to 0.7 volts. So there's a good bit of attenuation. I believe the transformer is a step-down transformer, and then there's some built-in attenuation. There's like a resistor here to ground for both of them before the diode. But what's basically happening here is the same thing that's happening in the 1176 and the LA4. It's just a variable resistor controlling a voltage divider. And in this case, it happens to be a diode. Now, I would love for somebody to chime in if I'm wrong, but I believe that this is kind of the earliest type of non-tube, non-varimu, non-pulse width modulation compressor. It predates the 1176 and the LA2A, I'm sure. But again, I'm not a historian, but I'm pretty sure this is one of the earliest types of compression. One thing that people typically want to know about different compressor types is how do they sound different? How does a FET sound different from an opto, from a diode, etc.? And I just want to say, I think that talk can be a little misleading because they do have different starting points, but really the sound of the compressor is going to come down to everything and the choices the designer makes, especially in the side chain in terms of how fast the attack and release and all that will be. But that out of the way, there are some peculiarities to a diode circuit. One is that, if you exceed this 0.7 volts, these diodes are basically just clipping diodes. You could really use this as like a distortion pedal if you gave it enough signal. So, FETs and optos are also going to have a point at which they clip, but it'll be a good bit higher than 0.7 volts. So you're more likely to get that with this kind of compressor. Another is that these diodes need to be very well matched. Otherwise, you're going to have some funky asymmetrical compression between the two halves of the balanced signal, which will look like asymmetrical distortion, which could be cool. What else? I mean, since you need to be at such a small signal level here, it means you need more makeup gain here. And so the makeup gain is going to be very important to the sound. And here we have the BA340, Neve's Class AB sound. So that's a big part of the sound of this unit is the makeup gain. But again, those things are kind of true of FET and opto compressors as well. So you really can overstate the differences between different compression types. So yeah, that's the 3630 in a nutshell. What a beautiful compressor to be able to tear down today. I certainly feel lucky to get to open this thing up. So I'm sure I'll be back at Retro City soon because they have a ton more gear that I want to look into. But thanks for following along, and I'll talk to you next time.